heavy conceptual things or like this one. Okay, so I'll move to the next slide. Next topic, that is EIGRP configuration. So hold on for a second. This slide is done. Okay.
provide it to somebody who is like a code one and can add more photos and everything. And we have all these features going on up here. And if I go back up here, this is the hire YouTuber where the form is going
So,
on. Like when you
can
submit.
you see the slides?
Yes, sir.
So the problem is sometimes Microsoft Teams has some bugs. I am facing in some cases. Okay, so hope they will cover it up soon. Software bugs. Okay. So the thing is when okay, now we'll go through the EIGRP, that is Enhanced Interior Gateway Routing Protocol. This is analogous to actually RIP, RIP, RIP. So we have seen RIP version 1 and RIP version 2, RIP version 2, so version 2. So RIP version 1 and 2, we have seen how to configure them in a computer network using Cisco Packet Tracer. Now EIGRP is similar type of routing protocol that is little bit different from the RIP version 2. We'll see them soon. We have so many, the computer network is a huge syllabus and it is a very short semester particularly. Always the class is not enough to accommodate all. We need some little bit of time. So we have to be hurry. So in past, in previous section, sorry, in previous part we have seen how VLAN works actually. And now we'll go through a rapid transformation to another topic, that is a routing protocol. Okay, so we'll see this routing protocol how it works. Okay, now let's see. So we'll see something that is metric network discovery EIGRP table, and then EIGRP configuration. So this is multiple times has been added. So we'll see the matrix. Actually, the matrix actually says the quality of the network. Okay, and the neighborhood discovery is a actually protocol that actually used to discover neighborhood protocol. Now this table is the routing table actually, and how to configure this one. Similarly, like RIP version 2. Okay. Okay. Now we'll see what is the difference between RIP routing information protocol and enhanced interior gateway routing protocol. Okay. The fundamental thing is it supports 15 router in uh, 15 support maximum 15 router in the network. So it has the maximum 15 router information and 16 non router is not actually reachable. Yeah, yeah. Whether in EIGRP, it has been developed and designed by the Cisco company. So it has the patent of EIGRP. So it actually supports 255 routers in the network. However, default is 100 router, which is quite enough to cover a part of whole country. Okay. Now, um, then slow convergence and the fast convergence and feasible success. So we'll see what is feasible successes, how it will be calculated in EGIRP. In routing protocol, we cannot create separate administrative boundary in the network actually, but in EIGRP we can create separate administrative boundary. Okay, that is the thing, and it has autonomous system number which actually isolate this system boundary. So the less routing table exchange is required in these cases EIGRP. So little bit uh, performance is better compared to the read. But the thing is, that is the thing, the feasible success, how it will be calculated. So it actually the network path from sender to receiver, how it will propagate. Okay, this is the thing. It called actually it calculates the matrix in terms of hop count from source network to destination. So hop counts mean number of actually router from source to destination. Yeah, and EIGRP actually matrix in terms of bandwidth and delay. So two things actually performance parameter. the what will be the performance parameter of EIGRP is actually bandwidth and delay. RIP works on actual Bellman-Ford algorithm. You have heard of this in from algorithm course. And EIGRP actually use diffused updated algorithm, new one, which not actually covered in algorithm courses, but this is almost similar to the Diascar or a combination of Bellman-Ford algorithm. So it is a combination of some other algorithm. Now it only maintains the base route to each destination. So it has the information of base route. So EIGRP has the base route and some other alternatives route for each destination. So it is basically used for a smaller size organization. So RIP for a smaller size organization, and EIGRP can afford more routers. So it could be actually adopted in designing large network. Okay, so these are the difference. Now see, so what are the metrics? So bandwidth, delay, load, and reliability. Okay, how they will actually they can be managed. So bandwidth, so it will be in kbps, link in kbps. So it actually depend on interface type. We have router interface, and we know each interface has bandwidth limit. So uses bandwidth limit between 1 to 10 into 10 to the power 7 uh, to say bandwidth in capacity. So this is not the bandwidth actually. This is some parameter that indicate the real bandwidth. So it has been written in the next line. It is not the real bandwidth. The real bandwidth depends on clock rate. So this refers to some sort of clock rate. Now the bandwidth command only influence route selection by routing protocol. So routing protocol actually responsible for the bandwidth command. If no bandwidth is set, then default bandwidth of the interface is considered. So we'll see later on in the next slide what will be the default bandwidth. So calculated as the lowest bandwidth among the all link routes. So actually we'll pick the lowest bandwidth among the all link to the source to destination route. We'll calculate during the metric. We'll see through example. You see, this is the default bandwidth column, and this is the delay column, default delay column for each interface. So if it is a serial P1 connection in previous generation, if you consider, you see the bandwidth is lower, only 1.5 Mbps, and it has a higher delay. You see, high delay. So it actually consumes much more delay. And Ethernet, so Ethernet is 10 Mbps, little bit better in terms of capacity, and still the delay is almost uh, compared to lower to the serial T1. Then fast Ethernet we have seen, we have used this one. Then this is 100 Mbps, and delayed microsecond is 100 microsecond. This is microsecond, 10 to the power 6. So this column is microsecond, okay? Not millisecond, microsecond, 10 to the power minus 6 order. So which is আপনি যদি 1 সেকেন্ডকে 1 মিলিয়ন দিয়ে ভাগ করেন, সেই ফ্র্যাকশন অফ টাইমে এই ডিলেটা আপনার ক্যালকুলেট হয়। সো গিগাবিট ইথারনেট যদি হয় আপনার হচ্ছে ইন্টারফেসে 100 Mbps, which is correspond to 1 Gbps, almost 1 Gbps, and it is only 10 microsecond, and 10 gigabit internet, so 10 Gbps, so it can 10 delays 10 microsecond. If nothing is mentioned in the link, then you can consider the default values for different interfaces. Okay, so let's see. Do you have any questions so far? So any questions so far? No. So delay is measure of time for packet to reach its destination over a route. In theory, in practice, is constant set by the network engineer. So delay and the value. So the value between 10 microsecond to this sort of huge microsecond. So আপনি চিন্তা করেন almost 3 minutes. 3 minutes. Around 10 microsecond to 3 minutes. So lower the delay, better the network performance. If the delay is not set, then default value will be table 2. We have seen the default values. Okay. Now calculate the sum of delay in the exit interface for all routes in the route. Okay. So exit interface এর মধ্যে যে কোনো interface where the data or packet is exited, it will calculate all those stuff, the delay. Okay. So how to calculate the metric? Okay, metric, the performance parameter of the link actually. So metric is 10 to the power 7, least bandwidth, the minimum bandwidth of the link. And this is the constant value. You cannot change this. And delay. Total delay will be there. This is another constant. You cannot change this one. Then the metric will be available. Now, what will be the least bandwidth? So it will be in kbps. The link গুলো থাকবে এটার মধ্যে যে minimum bandwidth, the minimum bandwidth you will find in the link from source to destination. That is the least bandwidth. And delay should be that you will find in the link. Each link has delay. So delay will be by default divided by the 10 always. Okay. The total delay will be divided by the 10. That is the ground rule. Okay. So then 256 is fixed, 10 to the power 7 is fixed, then calculate the metric. Okay. So can you আপনারা বুঝতে পারতেছেন আমার কথা বোঝা যাচ্ছে?
জি স্যার।
Okay. So I'm a little bit harsh, let's say. Now, so how to calculate this actually metric? Okay, see it carefully. Watch it carefully for route 1, 4, 2B. Okay, this is my equation. This is my equation, and I am from 1, 4, 2B. So this is my transmitter. Oh, sorry, this is my sender. This is my receiver. Okay, right. So the route is having 1, 4, 2B. So least bandwidth B is actually B is for bandwidth actually. So you can see B is for bandwidth. So here is B56. So for this link, B is actually 10,000 kbps for the network. This is not here B. This should be A. This is B. Suppose network B. Then here is 10,000 actually kbps. So what is the least bandwidth we have to take into consideration? So least bandwidth from 1, 4 to network A, or here it is network B. Suppose this should be A and this should be A. So in this particular path, the least bandwidth is 56 kbps. 56 kbps. Now what will be the delay? The delay will be 10, 100 divided by 10, 100 divided by 10, and 2000 divided by 10. So this is 220 microsecond actually. So then this is the value actually metric. If you consider 10 to the 7, 56, this if you this one, so consider 220 microsecond. So consider microsecond here. Then you will find some value. Okay. So it will be like the value you will obtain is the metric value. So এখানে যেটা করছে মাইক্রোসেকেন্ডে দেখছে, সেকেন্ডে নিয়ে আসেন, যদি সেকেন্ডে নিয়ে আসেন তাহলে এই ভ্যালুটা কমে যাবে. Okay. Now for another path, Is this okay? বুঝা গেছে? Any question? Any question? Any question so far? আপনাদের কোনো কোশ্চেন আছে? Any question?
No, sir.
Okay. Now, for route B, you will find similarly for this 1, 3, 2, B route. If you find the metric, okay, then I have the least bandwidth 128 kbps. Okay, and then 128 will comes here in the denominator. Then the delay 120 microseconds. So 1000 divided by 10, then 100 divided by 10, 100 divided by 10, so 120. So this is the metric value. Lower the metric value, higher the performances. Okay, that is the thing. Now for your this is your task right now. I'll give you 5 minutes to solve. So you will find the metric on the way to this is path A. Calculate the metric value, and in this way path B calculated the metric value. Okay, so you have got 10 minutes. I'll be back in 10 minutes and I'll ask you the answer. Okay. আপনাদের হয়েছে এটা? হয়েছে? হয়েছে? আপনাদের এটা করা হয়েছে? So how to discover the neighborhood? বললেন না? করতে পারছেন কি ওইটা?
জি
Path. Okay, good. Now we'll discover the neighbor discovery. How one router finds the neighbor of another router. So the way is we have seen the router may have multiple ports. Suppose in this way, so multiple ports. So actually, they actually R1 sent some message to R2 and it informed how much network connected to R2 to the R1. In the same way, R1 gets the R2 gets the information of R1 and R1 gets the information of R2. This is hello plus update. So this is short of three-way handshaking. They actually update their neighborhood discovery. If one is deleted, then this has to be updated instantaneously within 5 seconds. So there is some rules. Let's see. So so in the neighbor discovery process, full routing table is set. So routing table বেসিক্যাল থাকে যে আমার রাউটারের আশেপাশে কয়টা নেটওয়ার্ক কানেক্টেড এবং তাদের অ্যাড্রেস গুলো কি কি, ওকে, আইপি অ্যাড্রেস গুলো। So otherwise, only the change in route table is set. So if there is if that has been already to routers, then if there is only the changes in the network, that has to be actually sent. After neighbor discovery, the hello packet is sent each and every 5 seconds to know if the neighbor is still alive or not, whether the routers are functioning properly or not. They actually sends hello message. If the router does not receive the hello packet from neighbor within 15 seconds, called hold time, the neighbor is considered dead. So for low bandwidth link, this period can be extended up to 60 seconds or 180 seconds. Okay, so this way they actually discover the neighbors. So now EIGRP table discovery, how they actually discovered, how they actually made that. Okay, so you see a configuration out there. There is actually 6 router, 1 switch, and there is a IP address, and there is some neighbors. Suppose neighbors are R2, R3, and R4, and this is the destination. This is the source. Okay, source from switch থেকে source to destination. Now, how the reported distance and the feasible distance and the feasible successor will be actually continued or discovered. Okay. Now, in this process, so how they will be discovered. So the feasibility condition, the reported distance must be less than feasible distance through the successor. So reported distance must be less than the feasible distance through the successor. Okay, that is the thing. So one is reported distance should be less than feasible distance to be a feasible successor. So what is reported distance? Distance average from the neighbor as the distance between neighbor and the destination. So neighbor to the destination. If this is the source, this is neighbor to the destination, R5 to the destination. Then sum of reported distance. What is feasible distance? Sum of reported distance and the distance between router and the neighbor which reports the distance. So actually that reports the distance. So feasible successor is the route whose reported distance is less than the feasible distance of the best path. Now let's see how this works. Suppose, as I earlier you mentioned, the source to destination, actually source to destination, how the feasible distance and the reported distance will work in the table. Okay. So let's see from actually source to destination. So I am at switch one. So my neighbor is R2. R2. So from R2 from switch one. So this is R2. So distance. So I took the minimum routing path. মানে হচ্ছে যেখানে আমার কম router লাগবে. So in this way, actually, number of router in this way is 1, 2. Here, 1, 2, 3. So I'll choose the minimum routing path. So uh, the thing is, this is 1,000 and 5,000. That is 6,000 out there. Okay, R2. And for R3, R3, R3. So the reported distance is 1,000 and 10,000, 11,000. Okay, fine. So there is no alternative way, only one way. For R4, there is one way. There is 1,000 plus 17,000, 80,000. With this, fine. Okay. Now, what is the feasible distance? So feasible distance is actually the distance from source to sink. Okay. Or you can think from the reported distance to the destination distance. So here, my neighbor was R2. Okay, R2. So it was 6,000. Then we want to go to the destination. So this is 10,000. So 16,000. Or you can think of 1,000, 5,000, and 10,000. That is 16,000 to the destination. Okay. Now there is another thing that is from R3 to R1. R1. So R3 to R1. R1 is the destination. So it is actually 1,000, 10,000, 11,000, 17,000. So uh, actually 18,000. Okay, feasible distance. And for R4, it is 17, 18, and 4. So 22,000. Okay. So you see feasible distance is higher, all those cases. And the reported distance is lesser computed to the feasible distance. So all of the case, the answer is yes. They are all, in this case, it will be yes. So all of the things actually, so there will no. All of the case, the feasible is a successor. The feasible successor is the route whose reported distance is less than the feasible distance of the base path. Okay. So this is the thing what how to actually EIGRP table works. So it has basically three tables. Okay. One is neighbor tables, one is topology tables, another is routing tables. Okay. So আপনাদের any question? Do you have any question so far? আপনাদের কোনো question আছে? Can you hear me?
Yes, sir.
So far, any question?
No, sir.
No, sir.
Okay. Now, three types of tables out there. So one is a neighbor table, another is topology table, and another is routing table. So we have seen the routing table based on topology table and neighbor table. So EIGRP shares routing information only with their neighbors. To know who the neighbors, it uses neighbor table. Okay, so to discover the neighbor, they use neighbor table. When new neighbor is discovered, EIGRP would add it to the address and interface on which neighbor is connected, and in the neighbor table is updated. So কোন ইন্টারফেসের মধ্যে আছে সেটা আপডেটেড হয়ে যায়। Then topology table. Okay, topology table stores all feasible successor along with the base route, along with the successor, feasible successor and the successor, the base route for each destination network. So far we have seen EIGRP can store up to 32 feasible successor. So successor. So you can think that EIGRP can have 32 tables for a single route alternative. So which is a good thing. And routing table. So EIGRP stores single base route for each destination in the table. So in this case, it has the only base route for the source to destination. So basically, this table actually used to this base route actually used to forward packets from source to destination. So you can think of this figure actually. So there is SF router, this is NY router, this is the network. So this S00 interface and this is S01 interface. So they has neighbor of tablet entry থাকবে the SF actually San Francisco is in 00 interface and New York in the 01 interface. So in topology table, so if you want to actually your destination is this network 10.0 network, successor is this interface, and New York table destination feasible successor is S01 interface. So routing table has the only base route. So you have the base route. Okay. Now this way actually three table has been managed. So EIGRP configuration, when we use packet tracer, we have actually router and its interfaces. So it has three interfaces, suppose. So it has three interfaces, suppose. So one interface is actually 172.16.1.0 and 192.168.2.0 slash and 172.16.1.4. So these are the network information. So far we have configured RIP version 2, routing information protocol version 2, and there the network is 172.16.1.0 out there, and the network is three network entity we have used in this manner. Yes, and no auto summary. We know how to do this one. We have done this one before. Yes. এটা আগে করছিলাম না আমরা?
Yes, sir.
So if we want to configure EIGRP using actually the packet tracer will actually do exactly the same thing. প্রত্যেকটা রাউটারের ইন্টারফেস আমরা সিমিলারলি কনফিগার করব গেটওয়ে গুলো করে আমরা যেটা করব তখন রাউটার কনফিগ মোডে নিয়ে হ্যাশ মোডে নিয়ে আমরা যেটা করব ঠিক আছে EI router EIGRP then একটা autonomous number, it could be anything. So suppose it is 100, so it doesn't matter, you can always use 100. So it is a particular identity. So আমি যদি EIGRP দেখে এখানে যেমন রাউটার রিপ্লেক্সলাম ভার্সন 2 এই জায়গায় লিখবো রাউটার EIGRP একটা 100 দিয়ে দিলাম, দেন এখানে আমাকে যেটা দিতে হবে নেটওয়ার্ক 172 সব নেটওয়ার্কের সাথে এর আগে রিপে আমি কোনো আপনার হচ্ছে লগা সাবনেট মার্কস দেই নাই, কিন্তু এখানে আমার প্রত্যেকটা নেটওয়ার্কের সাথে সাথে আপনাকে সাবনেট মার্কস দিতে হবে এবং ফাইনালি বলতে হবে অটো নো অটো সামারি। সো দে আর এক্স্যাক্টলি দ্য সেম থিং। আমি কোন প্রোটোকল ইউজ করব ফাইনালি রাউটার কনফিগারেশন করার পরে, ঠিক আছে? So RIP version and EIGRP, and the process of implementing both of the routing protocol almost similar. The difference is we have to write the autonomous number node in case of EIGRP, as well as the subnet mask of the corresponding networks, the only the separating part from RIP version 2. So this is the thing actually we actually done in EIGRP configuration. So there is very small, uh, very small difference between them. So far, any question?
No, sir.
So আমরা বেসিক্যালি আজকে কিন্তু অনেক কিছু ভিলেন পড়লাম, ইআইজিআরপি রাউটিং প্রোটোকল পড়লাম, হাউ টু ইমপ্লিমেন্ট দেম, এগুলো পড়লাম। ঠিক আছে, আমরা ল্যাবে সর্বশেষ কি করছিলাম? ডিএসসিপি সার্ভার করছিলাম না?
স্যার ইমেল নিয়ে কাজ করছি স্যার, ইমেল।
হ্যাঁ হ্যাঁ, আচ্ছা 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 আচ্ছা। ওই নেক্সট ক্লাসে আপনারা এই যে করবেন, ইআইজিআরপি কনফিগারেশন করবেন, আরেকটা করব ওএসপিএফ সম্ভবত পপেট শর্টেস্ট পার্ট ফরওয়ার্ড যেটা আছে ওইটাও আমরা ইমপ্লিমেন্ট করব। ঠিক আছে, then you'll see actually all our theory, all our labs, they are very actually close together. So some more actually some more protocols. So show IP protocol. So if you want to which protocols you are using, you can write in the router command mode, show IP protocols, and if you want to see neighbor, then show IP EIGRP neighbor লিখলে পরে আপনাকে neighbor দেখাবে। Show topology, show IP EIGRP topology, which topology it is using, so we are using. Then IP route EIGRP, if you write which route, what is the route for IP address, then IP route EIGRP, then set maximum hops, then maximum hops is 1 to 255. Set number of feasible successor, so maximum path is 0 to actually 32. So feasible successor path, so কতগুলা পাথ তার কাছে আছে এগুলো আমরা ম্যাক্সিমাম পাথ কমান্ড দিয়ে দেখতে পারি। So you can try that. So that is the end of this EIGRP. Okay, so far any question?
No, sir.
So we may actually a little bit see what is DSCP network. Okay. So this is actually another lecture that is actually DSCP. This is DSCP and ERP. আমরা টোটাল পড়বো না, আমরা শুধু মেইন পার্টটুকু পড়বো, কারণ আমাদের অনেক ফাইনাল টার্মে অনেক বাকি, আমরা শুধু ফান্ডামেন্টাল টুকু পড়বো। ওকে, so what actually DSCP? So dynamic host control protocol and address resolution protocol. So these are two application layer protocols. They work in actually application layer. They have some specific tasks to do. So we'll know what is DSCP, how the DSCP works, the steps of DSCP. So ARP, what is actually address resolution protocol, how it works, and all those stuff, advantages, disadvantages. Okay. Now, the thing is dynamic host configuration protocol. So I'm control protocol বলছিলাম না, এটা configuration protocol. So dynamic host configuration protocol is a network protocol like static or dynamic. Static আমরা IP address দিই, ঠিক আছে? তো আমরা যখন স্ট্যাটিক আইপি অ্যাড্রেস দেই সেটা আসলে স্ট্যাটিক প্রটোকল, আর যখন আমরা ডাইনামিক অটোমেটিক আইপি অ্যাড্রেস চয়েস করে নিবে সেটা হচ্ছে ডাইনামিক হোস্ট কন্ট্রোল প্রোটোকল, কনফিগার control. Dynamic host configuration protocol is a network protocol that enables server automatically assign IP addresses to computer from the defined range of numbers configured for given network. So এটা network administrator network থেকে define করে দেয় পার্টিকুলার ওই নেটওয়ার্ক ওই ল্যানের জন্য আইপি রেঞ্জটা কত হবে বলে দেয়, পরে সার্ভার থেকে randomly using the DHCP algorithm, there is some, and using those algorithm, those actually process, actually the IP address has been assigned. So another thing is bootstrap protocol. So basic term bootstrap protocol. So this is another important protocol. So it is a networking protocol used in internet protocol network to automatically assign IP address to the network devices from configuration server. So এই প্রোটোকলটা যেটা করে automatically assign IP address to the network device from configuration server. When a computer is connected to a network, is powered up and boots its operation system, the system software broadcasts the boot TP message. So is the পুরো নাম হচ্ছে bootstrap protocol message onto the network to request an IP address assignment. Okay, ও যখন পাওয়ার অন করে অফ করি তখন এটা ও রিকোয়েস্ট করে সার্ভারের কাছে। ওকে, boot TP configuration server assign an IP address based on the request from a pool of address configured by the administrator. So it is actually also belongs to DHCP in case of networking devices, not for in devices. So for in devices, the clients they use DHCP. For network devices, suppose router or switches do not have. So any other network devices may have bootstrap protocol. Okay. So so what is the actual working mechanism of DHCP? So bootstrap, then DHCP discover, then initialization, then DHCP discover, selecting, then DHCP requesting, then data pack, then bound, then DHCP request 50% expand less time, then reviewing, then less time 87% expand DHCP request, then binding. All those process it is actually going on. So it follows this type of algorithm flowchart while actually we are connecting to the DHCP. So this bootstrap actually protocol actually carries the DHCP message. Okay. So step of DHCP. So we have initial step. Initialization step that client broadcasts the DHCP discover message. Okay. So message with DHCP discover option using port 67. So it uses transport layer port 67 to initializing this port using DHCP discover. So selecting stage. So after sending discovery message, the client goes to the selecting stage. Those server that can provide the service response to the DHCP offer message. So in this message, the server offer IP address. So selecting stage IP address offer করে. They can also offer lease duration, কতক্ষণের জন্য আপনার এই IP অ্যাড্রেসটা দেওয়া হবে। অনেক জায়গায় দেখবেন হচ্ছে একটা পার্টিকুলার টাইম পর্যন্ত আপনি ওয়াইফাই ইউজ করতে পারেন, দেন অটোমেটিক্যালি ডিসকানেক্ট হয়ে যায়। ঠিক আছে, সো ডিএসসিপিটা অটোমেটিক্যালি আপনার হচ্ছে আমার মনে আছে আমার হচ্ছে আমি যখন ইস্তাম্বুল এয়ারপোর্টে ছিলাম, আপনারা পাইছেন কিনা আমি জানি না, ওখানে আমাকে ডিএসসিপি দেওয়া হয়েছে যে আপনি 1 ঘন্টার জন্য ওয়াইফাই পাবেন ওই টার্মিনালে, ওই যা করতে হবে 1 ঘন্টার মধ্যে। ঠিক আছে, পরে অটোমেটিক ডিসকানেক্ট হয়ে যাবে। ঠিক আছে, একটা পাসওয়ার্ড আর হচ্ছে আপনার কানেকশন। সো 1 ঘন্টা পর অটোমেটিক ডিসকানেক্ট হয়ে যাবে। এটার জন্য একটা কপি কিনতে হয় মনে হয়, ঠিক আছে, বা সামথিং, না কিনলেও চলে ফ্রি হিসাবে। এরকম কি বাংলাদেশে আছে কোনো জায়গায়? ধরেন হচ্ছে ধরেন আপনাকে 20 মিনিট বা 30 মিনিট দেওয়া হবে, পরে হচ্ছে ডিসকানেক্ট হয়ে যাবে। So these selecting steps go through more processes. Okay. So it tries 4 times. It tries 4 times each with a span of 2 seconds. If there is no replay to any of this DSCP discover, the client sleep for 5 minutes before trying again. So there is well established actually algorithm. So requesting state the client remains in the request state until receive the DHCP package from the server. That creates the binding between client physical address and its IP addresses. After receipt of DHCP acknowledgement, the client goes to bound state. So what happens in the bound state? In this state, the client can use IP address until the lease expires. So at our home, actually the lease expires when we disconnect or close the in devices. Otherwise, it always carries on. When 15% of the lease period is this, the client actually sends another DHCP request to ask for renewal. Okay. Uh, it then goes for renewal, renewing stage. When in the bound state, the client can also cancel the lease and go to initialization stage. So you can actually again start after, or you can actually uh, renew your connection. Okay, bound state. So renewing state কি হচ্ছে, client remains in the remaining stage until one of the two events happen. It can receive the SCP pack, which renew the lease agreement. In this case, the client actually resets its timer and goes back to the bound state. Okay, or the DHCP is not received and 87.5% of the lease time expired, the client goes to the rebinding state. So what rebinding state does, it remains in the rebinding state until one of the three events happens. If the client receives DSCP negative acknowledgement, the lease expires. Okay, it goes back initialization state and tries to get another IP address. If the client receives a DSCP positive acknowledgement, it goes to the bound state and reset the timer newly. So these are the thing. So DSCP actually explain. So this is client, this is server, and DSCP discover, DSCP offer, DSCP request, and DSCP acknowledgement. The whole four-way communication has been established. So next class আমরা ARP পড়বো, ঠিক আছে? দেন হচ্ছে লোক হাউ অ্যাকচুয়ালি এআরপি অ্যাকচুয়ালি হচ্ছে লোক আপনার ম্যাক অ্যাড্রেস ফিজিক্যাল অ্যাড্রেসকে আপনি ম্যাপ করে লজিক্যাল অ্যাড্রেসে সো দিস ইজ হাউ এআরপি ওয়ার্কস সো নেক্সট ক্লাসে আমরা এআরপি পড়বো ওকে নো নেক্সট ক্লাস আমাদের কবে থিওরি ক্লাস থার্সডেতে তো আমাদের এই ল্যাব ক্লাস না স্যাটারডেতে হচ্ছে হলো ওয়েডনেসডে ক্লাস ওকে ওকে সমস্যা নেই আমরা করে ফেলবো আমাদের আর কয়টা ক্লাস বাকি 13 তারিখে ক্লাস পাবো আর পরে মনে হয় পাবো না আচ্ছা লেটস সি কতটুকু যাওয়া যায় ওকে ক্লাস সিরিয়াল 1 2 Class result 2, class result 3, class result 4,
Yes, sir. Yes.
5,
স্যার আনামুল হক খান
6,
Yes, sir. Sushma.
7,
Yes, sir. Mahbub Rahim.
8, 8,
Yes, sir. Moshiur Rahman.
9, 10,
নাজনীন সরকার স্বর্ণা।
11,
Yes, sir. Deepta Mondol.
12, 13,
Yes, sir. Fahim Farah Jannat.
14,
Yes, sir. Mushfiq Alam.
15,
Yes, sir. Yes, sir. Imran.
16,
Sir Rakib Hassan.
17,
Yes, sir. Khan Shubho.
18,
Yes, sir. Shamil Sultana.
19,
Yes, sir. Isra Jahan Anika.
20,
Yes, sir. Shumana Islam.
20, 21, 22,
Yes, sir. Ashraful Islam.
23,
Yes, sir. Sumay bint Nasir Tudini.
24,
Yes, sir. Hossan Amdi Iqbal.
25,
Sir Sadia Emma.
26,
Yes, sir. Habibur Rahman.
27,
Present, sir. MD Rakibul Hassan.
28,
Yes, sir. Mustad Mustawi.
29,
Yes, sir. Tanvir Shahriar.
30,
Yes, sir. Nabil Siddiq.
31,
Yes, sir. Fikra Basit Bosheki.
32,
Yes, sir. Tasnim Haq Hriday.
33, 33, 34,
Yes, sir. Nasir Khan.
35,
Yes, sir. MD Rafigan.
36.
Yes, sir. Sabbi Mahmud Prantam.
We have a quiz tomorrow. Okay. So be there.
Okay, sir.
So the class is over. You
Assalamualaikum.
leave the class.
Assalamu alaikum, sir.
All right.